Quantifiable fine-grain occlusion removal assistance for efficient VR exploration. Consider a VR application where the user has to find a person in a group of people. The user has to first walk up to the group and then walk around to search for the person. If the person is not in the group, the effort is wasted, and the user has to continue with the next group. The wasted effort is particularly costly when it implies multiple disorienting redirections that are necessary to keep the user in the limited physical space available to the VR application. We propose a method for improving VR exploration efficiency based on intuitive occlusion management. Here our method has detected a region with fine-grain occlusions, and it signals to the user that a disocclusion effect is available inside the green rectangle. The user engages the disocclusion effect and explores the group of people, from the current user position, with small lateral head translations. The user can also engage a zoom-in effect that magnifies the region of interest. This overhead visualization shows that the disocclusion effect is constructed by rendering the virtual environment with a multi-perspective camera with piecewise linear rays. The rays bend twice to show the group from multiple view directions, while keeping the center of the group in place. The ray bends are animated by the small user head translations which are amplified to achieve the desired disocclusion effect. The geometry close to the user, such as the nearby columns here, is rendered conventionally, from the user viewpoint, to anchor the user and avoid disorientation and simulator sickness. Our method also quantifies and localizes the volume of the scene that is yet to be disoccluded from the current reference viewpoint. The percentage of residual occlusion H decreases as the user disoccludes new parts of the scene, which are visualized with purple dots. This helps the user ascertain that a region of the virtual environment has been fully explored before moving on to the next region. We have evaluated our occlusion management method in 3 controlled user studies. In the first user study, participants were asked to search for 7 persons wearing a specific shoulder badge in a crowded art gallery. With conventional visualization, a user has to walk up to the crowd and then move around it to search. With our method, the user can search the crowd from multiple view directions, from the current user position. With our method, participants found more people, faster, and with less navigation. In the second user study, participants were asked to find 3 trees in a large Chinese garden environment and to count the apples in these trees. With conventional visualization, the participant had to walk long distances to find the trees, and then to find and count the apples. With our method, participants were able to locate the trees more easily, from afar, avoiding unnecessary viewpoint translation. Once a tree was found, participants can observe the tree from different view direction at a distance. The zoom-in feature of our disocclusion effect allowed finding and counting apples more easily. In the third user study, participants were asked to search for small cubes hidden in an indoor scene. Both groups of participants could use our disocclusion method. The experiment group also benefited from our occlusions quantification and localization effect. The added benefit allowed the participants to search thoroughly, finding more cubes faster. We have presented a method for improving VR exploration efficiency through disocclusion assistance. Our method detects VE regions with an abundance of fine-grain occlusions, which the user can then explore from afar, from multiple view directions, resulting in a significant increase in VR exploration efficiency, as confirmed in 3 user studies.